Welcome to Standex Mentor Electronics Latching and Form B Read Relay and Sensor Training Module. This module will define key terms of Form B and latching sensors and relays. This module will also describe the structure and functioning of latching and Form B read relays and sensors. Contact refers to the contact blades making up a reed switch or electromechanical relay. The contact configuration used for a given design or application is typically described by its contact forms such as 1 Form A, 1 Form B, etc. Contact Form A is a single pole, single throw, normally open switch. Contact Form B is a single pole, single throw, normally closed switch. Contact Form E is a bistable contact that can exist in either the normally open or normally closed state, such as in a latching relay or sensor. Reversing the magnetic field causes the contacts to change their state. It is important to first review some of the key terms used by engineers to describe various reed products. The next two slides define the terms used in this training module. A bias or permanent magnet is a steady magnetic field that applies to the magnetic circuit of a relay or sensor to aid or impede operation of the contacts. An electromagnetic assembly consisting of one or more windings of copper insulated wire, usually wound on a bobbin or spool, is a coil. When a current is applied to the coil, a magnetic field is generated, operating the contacts of a reed relay or electromechanical relay. De-energize is the act of removing power from a relay coil, while energization is the application of power to the relay coil. A reed switch or reed sensor is a switch that uses glass-enclosed magnetic reeds as the contact members, which includes mercury-wetted as well as dry contact types. A reed relay is a relay that uses one or more hermetically sealed reed switches. Normally open, or Form A, contacts represents a state of contacts before any magnetic field is applied to them in which they exist in the open state. Conversely, normally closed, or Form B contacts represent the state of contacts before any magnetic field is applied to them in which they exist in the closed state. A latching relay is a relay that maintains its contacts in the last assumed position without needing to maintain coil energization. To change the state of the contacts, the magnetic field must be reversed. In every normally open Form A reed relay, there are one or more reed switches that perform the actual switching function. These reed switches are in their natural, normally open state. When voltage is applied to the coil of the relay, a magnetic field develops around the reed switch, closing the contacts, carrying out its intended switching function. If the customer has an application requiring that the relay remain closed for long periods of time, as is the case for many safety circuits, power will be continuous for that stretch of time. Standex Mentor has developed a normally closed Form B reed relay in order to allow extended periods of contact closure while eliminating continuous power draw. To configure the reed switch in the normally closed state, a permanent magnet is required and mounted directly to the reed switch, both of which are internal to the actuating coil. The normally closed state is achieved by adjusting the magnetic strength of the magnet for proper operation. Proper magnet adjustment is achieved when the magnet will suitably close the contacts but still allow them to reopen once the coil power is applied. Once this is achieved, the reed switch will remain in the closed state with no external power applied to the relay. Therefore, the relays can stay in the closed state, never drawing any power for long periods of time. To open the contacts, the relay coil is energized by applying the nominal voltage to the coil. The nominal voltage is usually 5, 12, or 24 volts. This is usually selected by the customer depending upon what DC power supply he is using. When the coil of the relay is energized, it produces a magnetic field that is at least equal and opposite the permanent magnet. This electromagnetic field produced by the coil effectively nulls the magnetic field present from the permanent magnet. This in turn opens the reed switch. The normally closed reed relay will maintain its closed contacts as long as no power is applied to the relay coil. The permanent magnet's strength will not change, thereby ensuring the contacts will stay in the normally closed state until a switching requirement is needed. Applying the nominal voltage to the coil with the proper polarity will fully open the contacts. Care must be taken to make sure the polarity of the coil is maintained so that an opposing field is created, negating the magnetic field of the permanent magnet. If you reverse the coil polarity, the magnetic field of the coil will be aiding the permanent magnet and the contacts will remain closed. Once the coil is de-energized, the contacts return to the normally closed state and will remain there as long as no power is applied to the relay coil. A latching reed relay has two bistable states. The contacts can exist in either open or closed state without requiring any coil power. The latching relay generally has two coils, one that latches or closes the contacts, and a second one that unlatches or opens the contacts. To accomplish the latching or unlatching, typically a 1.5 millisecond pulse is required across the appropriate coil. The latching relay, like the Form B, normally closed reed relay, also requires an internal magnet for proper operation in the latching and unlatching state. In this case, the magnet is only partially magnetized, which does not entirely close the contacts. The contacts still remain open until the coil pulse is applied. With the contacts in the open state, a 1.5 millisecond nominal voltage pulse with the correct voltage polarity is applied to the latching coil. This voltage pulse will create a magnetic field from the coil windings of the latching coil that is an aiding field to the permanent magnet and thereby closing the contacts. Interestingly, the contacts will remain in the closed state after the latching pulse has gone away. Here again, the relay sits with its contacts in the closed state with no power applied. Now with the contacts in the closed state with no power applied to the latching coil, a nominal voltage pulse of 1.5 milliseconds is applied to the unlatching coil. The unlatching coil now produces a magnetic field that is opposite the field of the permanent magnet and thereby opens the contacts. Once the coil pulse is removed, the contacts will continue to remain in the open state. Again, applying the wrong polarity to the unlatching coil will have no effect on the state of the relay. So it is important to observe the correct polarity for proper operation. Reed sensors like the reed relays use a reed switch as their key switching element. And like the reed relay, these reed switches exist in their normally open state. The reed sensor can consist of simply a bare reed switch or a packaged device having one or more reed switches. In some applications, the customer may feel it's critical that the reed sensor be normally closed. A Form B reed sensor is a normally closed reed sensor. As we have seen with a normally closed reed relay, a permanent magnet is used to close the contacts. The magnet's size and strength are carefully chosen to ensure that the reed switch is fully closed. In this fully closed state, the contacts will remain in that state for as long as necessary. Also, the magnetic polarity must be consistent and well marked on the sensor. To open the contacts, a magnet of opposite polarity is brought into the existing magnetic field, canceling the field from the existing permanent magnet. This in turn opens the contacts. The magnet must be carefully chosen so that its strength is strong enough to cancel the field from the permanent magnet, but not too strong that it overpowers the permanent magnet's field, which could reclose the contacts. Furthermore, care must be taken in selecting the physical operate and release points. There are typically 3 magnetic lobes to deal with. Knowing where these lobes are is essential for proper operation. For normally closed sensors, it's best done working closely with Standex meter application engineers. Once the magnet is withdrawn from the vicinity of the reed sensor, the contacts will reclose. They will stay in that state until a permanent magnet is brought back within the influencer of the sensor. The latching sensor is similar to the latching reed relay. We also use a permanent magnet that is partially magnetized such that the contacts will come closer together but still remain in the open state. Bringing a magnet into the influence of the latching reed sensor with an aiding field to the existing permanent magnet inside the sensor will cause the reed contacts to close and remain so once the second magnet is removed. Applying a second magnet again, but with its field reversed, will apply an opposing magnetic field to the latching reed sensor, which in turn opens the contacts. The contacts will remain in the open state once this second magnet with reverse magnetic field is removed. As a technology, the reed switch can be used in a Form B normally closed state, as a normally closed reed relay, and or a normally closed reed sensor by the addition of an internally placed permanent magnet. In a like manner, the reed switch can be used in its latching state as a latching reed relay and or a latching reed sensor, also by the addition of an internally placed permanent magnet. These states can be very beneficial to the customer by dramatically decreasing the amount of power consumption.